4:23 a.m., January 23rd. Deep in the woods near the Belarusian border, the forest is silent. 15 degrees below freezing, snow thick enough to swallow sound. If you stood outside the perimeter fence of this classified military complex, you'd hear nothing. No diesel engines, no radio chatter, and no movement. Just the kind of silence that looks normal. But 300 miles overhead, an American reconnaissance satellite isn't fooled by silence. Its thermal imaging sensors see something the human eye cannot. The ground is glowing. Inside that frozen forest, beneath layers of camouflage netting and reinforced concrete, the earth is radiating heat like a furnace. To a civilian analyst, it might look like faulty HVAC. But to the intelligence officers inside a bunker in Kyiv, their screens tell a different story. Thermal signature, 280% above baseline. Power consumption, sustained high-load operations. Traffic pattern, inbound only, nothing leaving. They aren't running drills. They aren't conducting maintenance. They are assembling Russia's newest nightmare, the Oreshnik hypersonic missile system. Each launcher alone is valued at roughly $300 million. The entire battery staged behind those walls? Over $4 billion in strategic deterrence. Russia engineered these systems to bypass every shield the West possesses, to strike before interception was even theoretically possible. But Ukraine isn't planning to chase hypersonic missiles through the stratosphere. That's a game designed for them to lose. Tonight, they're going to kill the weapon before it ever leaves the ground. And the Russians assembling it? They have absolutely no idea the trap is already closing. This operation didn't begin with fire and steel. It began with patience. For 15 consecutive days, Ukrainian intelligence watched. Every satellite pass and every signal intercept, every infrared anomaly meticulously logged. They tracked the traffic rhythm. Massive transport trucks entering the facility every 50 minutes, like a heartbeat. Rail lines dormant for 3 decades suddenly reactivated, hauling sealed containers under cover of darkness. Everything flowing in, nothing flowing out. By 4:30 a.m., the pattern became undeniable. This wasn't a temporary staging area. Russia was consolidating its most valuable strategic asset into a single, hardened complex. They were concentrating force, turning what should have been distributed targets into one catastrophic vulnerability. Then came the decisive moment. Satellite imagery confirmed all 10 Oreshnik launchers, the 40-ton transporter erector vehicles capable of launching missiles no defense system could reliably intercept, were now parked within a 2,000-foot radius. Command modules, fuel trucks, fire control systems, calibration equipment, everything. The base had transformed from a dispersed deployment into a single point of failure. Inside the Ukrainian command center, junior officers were practically shouting, "We have the shot! Authorization to strike, now, before they relocate." But the senior planners held firm. Negative, hold fire. They understood the calculus. A premature strike might destroy 20 to 30% of exposed equipment. Russia would absorb the loss, rebuild within weeks, and disperse the remaining launchers beyond reach. Ukraine didn't want to damage the Oreshnik program. They wanted to erase an entire production cycle, to destroy components Russia could no longer replace under sanctions, to eliminate strategic capability for months, not days. So they waited. It was a brutal gamble. Every hour increased the risk of relocation. If those launchers dispersed, the opportunity would evaporate. But if the thermal signature spiked again, security protocols activated. The base entered operational lockdown. The trap was full, and it had locked itself from the inside. The strike doesn't open with an explosion. It opens with deception. 2 Ukrainian F-16 climbed to altitude deep inside friendly airspace, over 100 miles from hostile territory, well beyond the engagement envelope of Russian surface-to-air systems. They don't carry multi-million-dollar precision munitions, not yet. They carry ADM-160 MALDJ decoys. Cost per unit, roughly $250,000. a rounding error compared to the $4 billion target waiting in the forest. The moment the decoys separate, their wings deploy. Miniature turbofan engines ignite. But here's the genius. Onboard electronic warfare modules activate, broadcasting radar signatures designed to mimic formations of American B-52 strategic bombers. To the Russian S-400 Triumph air defense network, Moscow's most sophisticated shield, the system they've assured the world is invincible. These cheap decoys don't register as UAVs. They register as a massed, high-altitude strike package. Inside the Russian Air Defense Command vehicle, alarms scream. Radar screens flood with threat indicators. The system's threat assessment algorithm calculates intercept solutions and automatically escalates to launch authorization. The operators don't question it. They've been trained for exactly this scenario, and the night sky erupts. The S-400 battery unleashes 848 N6E3 interceptor missiles in rapid sequence, each one screaming toward the upper atmosphere at hypersonic velocities, each one costing $2 million. In 5 minutes, Russia burns through $22 million chasing phantoms. But the financial loss isn't the strategic blow. The time is. After expending its ready missiles, the S-400 enters a mandatory reload cycle. This isn't a video game. Reloading requires hydraulic cranes, specialized ground crews, and coordination between multiple support vehicles. In freezing temperatures, the process takes a minimum of 35 minutes. For the next critical window, Russia's premier air defense umbrella is functionally down. The radar crews are likely celebrating. Their systems logged confirmed kills. Mission success. But celebration doesn't reload missile tubes. It doesn't compress physics. And it doesn't change the fact that modern air defense can only look in one direction at a time. The S-400 isn't broken. It's designed for high-altitude threats, exactly what it just engaged. The problem isn't incompetence, it's geometry. You can't watch the sky and the ground simultaneously with the same radar frequency. The Russians followed their doctrine perfectly. They engaged the threat their systems identified. They executed the correct response. They just had no way of knowing the real attack was already screaming toward them at treetop level, completely invisible to sensors now committed to the wrong altitude band. While Russian operators stare at empty sky, the second phase closes the noose. 10 long-range Ukrainian UJ-25 drones cross into hostile airspace, flying at 125 feet above ground level. These aren't sophisticated platforms. They're built from composite materials and powered by commercial engines that sound like lawn equipment. Individually, they're barely threatening, but as a synchronized swarm, they're a nightmare. They execute erratic flight patterns, sharp banks, altitude variations, overlapping flight paths, deliberately designed to overwhelm fire control algorithms. Now the burden shifts to Russia's Pantsir S-1 short-range air defense systems. These are mobile platforms mounting dual 30mm autocannons and short-range missiles, designed specifically to kill low-altitude threats like drones and helicopters. But there's a hard limit. Each Pantsir can reliably track and engage 4 targets simultaneously. Suddenly, operators are staring at 5 contacts converging from multiple vectors. The system saturates. Target handoffs between radar and electro-optical sensors begin to lag. Threat prioritization algorithms stumble. Reaction time stretches by over 44%. The Pantsir gunners open fire. The 30mm cannons roar to life at 3,000 rounds per minute. Tracer fire arcs through the darkness like neon threads. The sound is deafening. A mechanical scream tearing through the frozen air. They destroy the drones, every single one. From a tactical perspective, it looks like a victory. But strategically, they've just lost. Why? Because every second spent tracking cheap, expendable UAVs is a second the fire control radars aren't scanning the horizon for cruise missiles. Every burst of cannon fire heats gun barrels, depletes ammunition reserves, and creates thermal signatures that mark their exact positions. The defense network is now engaged, predictable, and blind. And that's exactly what Ukraine needed them to be. 5:50 a.m., miles away. Outside hostile airspace, a second F-16 executes the decisive strike. 4 AGM-158 JASSM cruise missiles separate cleanly from the weapons pylons. Compared to the $4 billion target complex, these weapons are almost cheap, roughly $1 million each. The entire salvo, under $6 million. The moment they release, they don't climb, they dive. Within seconds, each missile levels off at 60 feet above terrain, lower than most residential rooftops, hugging valleys and tree lines with inhuman precision. At that altitude, ground-based radar systems struggle. The missiles vanish into what's called ground clutter, the chaotic radar return from hills, forests, and infrastructure that makes distinguishing real threats nearly impossible. The Russians activate wide-spectrum electronic jamming, attempting to corrupt GPS guidance and force navigation failures. But the JASSM doesn't need GPS. Each missile carries an imaging infrared seeker paired with a digital terrain reference system. It sees the ground in thermal wavelengths and continuously compares what it sees against a stored 3D map, updated every 0.16 seconds. Even if every satellite constellation went dark, even if the electromagnetic spectrum became pure noise, these missiles would still find their target. They aren't programmed to strike the primary blast doors. That's reinforced concrete over 7 meters thick, nearly impossible to penetrate. Instead, they're aimed at structural vulnerabilities, ventilation shafts, emergency egress corridors, pressure relief channels, points where concrete thickness drops below 2 meters. They hit at over 590 miles per hour. But they don't detonate on impact. Delay fuses trigger only after penetration, detonating deep inside enclosed volumes, maximizing internal overpressure rather than surface fragmentation. What follows is no longer a question of tactics, it's pure physics. 6:09 a.m. Inside the sealed bunker complex, containment margins are instantly breached. The warheads detonate in confined spaces packed with solid fuel rocket motors, energized, volatile, and stacked in close proximity. Solid rocket fuel doesn't behave like gasoline or diesel. It doesn't require external oxygen to combust. It is oxygen. And once ignition begins, the reaction is self-sustaining and uncontrollable. Temperature inside the bunker surges past 4,700 degrees Celsius in under 2 seconds. Internal pressure exceeds structural tolerance almost immediately. Steel blast doors weighing 10 metric tons are forced outward, not pushed, but launched, traveling hundreds of meters before impacting the forest floor. The primary roof structure collapses inward. Secondary ignitions propagate through adjacent storage bays. The thermal plume climbs to over 700 meters, visible to civilian infrared satellites in low Earth orbit. Seismic monitoring stations register ground motion equivalent to a magnitude 2.1 earthquake, confirming this isn't a single detonation. It's a cascading chain reaction. 2 Oreshnik launcher vehicles attempt emergency evacuation. Drivers sprint to the cabs, engines roar to life. But it's already over. The shock wave reaches them first. Fuel tanks rupture. The hypersonic missiles they were designed to carry, weapons engineered to penetrate any defense, cook off in their launch tubes. By the time the initial fireball subsides, the site is no longer recognizable as a military facility. By sunrise, the smoke begins to thin. The damage assessment is absolute. All 10 Oreshnik launchers, $400 million each, reduced to molten scrap. Command modules, fire control systems, fuel loaders, and calibration rigs. But the strategic loss goes far beyond hardware. Russia didn't just lose equipment. They lost 15 months of synchronized production. They lost components no longer available under international sanctions. They lost irreplaceable expertise as experienced operators died in the initial collapse. The financial toll? $4.6 billion. Ukraine's investment? Under $10 million. Return on investment? 460 to 1. But the deeper wound is psychological. Russia designed the Oreshnik system as a deterrent, a weapon so fast, so unstoppable, that its mere existence would reshape strategic calculations across Europe. Instead, the unstoppable system was destroyed before firing a single shot. The myth shattered in minutes. And now, every other Russian strategic commander is recalculating. If the Oreshnik could be erased this completely, what else is vulnerable? This wasn't a victory of firepower. It was a victory of intelligence, timing, and patience. Ukraine proved that in modern warfare, the most dangerous moment for a weapon isn't when it's screaming through the atmosphere at Mach 10. It's when it's sitting on the ground, surrounded by everything needed to make it work. They used decoys to blind the defenses. They used drones to saturate the sensors. They used precision missiles to strike the heart. A multi-billion-dollar strategic program was wiped from existence, and it never saw the strike coming. Somewhere in Russia tonight, another system is being assembled. Now, I want to hear from you. What was the critical factor in this operation? Was it the deception, tricking the S-400 into wasting interceptors on Phantoms? Was it the patience, waiting for Russia to consolidate everything into one target? Drop your answer in the comments. And if you want to keep following how technology is rewriting the rules of modern conflict, hit subscribe and stay locked in.